Hello, everyone. Welcome to the buildingSMART International Standards Summit 2020. We are also broadcasting as an EU Climate Pact presentation. So to get started here, this is the joint session between the Building and Sustainable Energy Management Room. It is on the BEM to Building Energy Modeling Workflows report. And we want to talk a bit of summarizing the report and then talk about the next steps in moving forward. So I'm joined here by Mirbek Bekboliev and Gianluca Genova. And let me advance this slide. We just wanted everyone to know that this webinar is a part of the buildingSMART 2020 Standards Summit in Montreal, that buildingSMART is committed that participation in development of standards is unrestricted and the process for the adoption is transparent, and standards are developed do not favor any particular provider and are open and non-binding and accessible to all. So please take note of our code of conduct. And there is a link here to read the full document as necessary. Okay. So what we want to do today is we want to go over the report on IDM development for BIM and BEM workflows, and then we want to look at the next steps moving forward. As was in the recommendations, we feel like there's a lot of opportunity for not just the BSI community, but many of our industry partners to come together and see how we can address the BIM to BEM workflow and interoperability issues. So we'll do a quick project summary. We'll look at some of the results and the next steps, and then Mirbek and Gianluca will also do a demonstration of what documentation of a use case looks like, how we sort of proceed with some of these projects, get everyone sort of acquainted with using the use case management platform. And then after their presentation, we'll have a discussion. I'll walk through some of the things that we need to consider as we move forward. So again, we are presenting this also as a part of the European Climate Pact educational efforts. And this event is dedicated to green building topics. And we want to show how, open standards and building information modeling combined with building energy modeling can be used to reach those goals from the UN sustainability development goals and EU Climate Pact goals towards reducing our carbon footprints, providing better efficiency, and having a more sustainable society. And there's a lot of work that needs to be done in order to meet this idea of a climate neutral economy by 2050. And we think that the efforts that we're undertaking there are just a piece, but a significant piece of trying to reach those goals, especially as we go through digitized workflows. In working with the European Climate Pact, obviously we're trying to provide another source of information from another part of the overall larger industry. We understand that industry is global and not just European. Hopefully as a community, as the buildingSMART community, we can have an impact common to those goals. And we realize this is important because we know that the energy consumption in the building sector is about 40%. And this is true not just to the EU, but this is true, I think, globally too, in terms of percentage of energy consumption. And we realize that a lot of the work that we do, if we had more information from the very beginning, if we had more data on the way that buildings operate, that systems operate, that people behave, and their behaviors in the operation of those buildings, that we could have a much more significant impact on the energy efficiency of these buildings. And so when we talk about reducing energy consumption, we're also talking about making not just new buildings more efficient, but we're also talking about making existing buildings more efficient. And so that is a topic that it has been a part of or added to this report. So let's dive, oh, one more slide here. We talked earlier about the Sustainable Development Goals of the UN. And within buildingSMART itself, we've also talked about aligning with those goals, in particular with this idea of the digitization or digitalization of the industry and the use of open BIM standards. We can look at a number of those principles and have direct impact on those goals. So let's get into the heart of this. So the report, which was started almost 4 years ago, was really a transformation of an existing project that started as a simple, oh, well, we want to create a data exchange based on IFC4 to provide a sort of a handover view for owners from a building energy modeling tool and a BIM tool to do sort of a pre-occupancy analysis. So having all of the as-built information in the hands of the owner and the sustainability or building energy consultant, and look at what was potentially the performance of the building as it turned over into operations. But while we were working on that project, we began to realize that we didn't have a full scope or understanding of the issue and how this was going to be applicable at a larger scale. It was really just dealing with a couple of different tools. It was just dealing with one particular energy modeling tool. And really from a buildingSMART perspective, it needed to be broader, more software and methodology agnostic to have the best impact. And so we stepped back for a moment and said, well, we really need to do the work to frame this problem. And really what we wanted people to understand is that we weren't trying to solve all BIM problems or all building energy modeling problems. What we wanted to do was really focus on what does it take to exchange data between these two domains within designing buildings and creating data on the BIM side, as well as creating and leveraging that data on the building energy modeling side. And so, we said, well, let's establish a common baseline of knowledge. Let's pull together all these things that we know are factors about these workflows and maybe why we've had so many challenges in the past. So we're at the point where this report, after some feedback from the expert panel and the room steering committees, is we've done a revision and it is currently under review by the standards committee. I'm keeping my fingers crossed we have this published before the end of the year. So we're really looking forward to that. The report itself has 8 parts, executive summary, introduction, problem statement, the precedent efforts, a BIM life cycle overview, the proposed life cycle data exchanges, recommendations, and appendices. And I'm just going to do just sort of a quick summary of all these things. And then what we'll do after Mirbek and Gianluca's presentation is really focus on the recommendations part. Because this is where we really want to step forward. So as we set this up, what we were trying to do is make sure we fully understood the issues before us. I mean, I think many times, many of us are so involved in the things that we're doing every day that when we start to talk about some of these issues, they're matter of fact. And the problem with that is that oftentimes you gloss over these, or you're making assumptions that everybody knows the same thing you do and everybody has the same assumptions. So the report really sets down and says, okay, we're going to assume that nobody knows anything or that everybody knows nothing. Because it gives us an opportunity to educate not just ourselves in developing the report, but making sure that everybody who's involved as a stakeholder in one way or another also comes to the table with the same level of knowledge and a consensus on what the issues are. And so we wanted to make sure that we understood, even the previous work that had been done, not discount it, not criticize it, but really recognize what was there and what was attempted to be done. And then recognizing that, within the BuildingSMART community, it's very easy for us to sort of slip into a default about talking about IFC and exchanges, but there's a lot of other technologies and process and standards out there that are also applied, and not just to data exchange, but also the technologies involved on the building energy modeling side, simulation and analysis, that are very different from each other. There's no one tool, there's no one single methodology. And then one of the important things that we do towards the end is we actually propose use cases. So these possible exchanges. Now, they're not set in stone and they are proposals, but we wanted to do this to create a starting point for action moving forward. So we're really at the end of the first phase of this project. And what we want to start getting into is looking forward to phase 2. And phase 2 is really set to begin the development of these data exchanges that were identified, or find out if there were other exchanges that maybe should be further explored and developed and attached to projects that then move forward for full execution. And as I said before, we went through, first version of the report, then we presented it to an expert panel. Again, all of my thanks to those who participated in the expert panel. They spent about 4 months looking at the report and going through and providing feedback and comments and further reference materials on the project. And we ended up with about 350 new data points or feedback comments from 9 different groups of stakeholders. In some cases, they represented individuals or individual companies, or they represented entire groups like the International Building Performance Society, and even things like the University College of Dublin. Is that how it's? Yeah. So there were a lot of great input, a lot of experts, even from the other chapters. What that meant, though, is that this report grew, and grew not so much in complexity, but in just the amount of baseline knowledge we really had to recognize we needed to document and share. And so much of this was really the cataloging or the documenting of these additional precedent and background materials. And I think this is important because a lot of research has already been done in talking about digitization and talking about what are the best ways to, or what's the best data that's necessary in order to do building energy modeling. How do building energy modelers feel about interacting in a BEM based process and workflows? And we want to make sure that we're very transparent and we recognize those previous efforts. And there was also a bit of tinkering with the format, but I think we did a really good job in better stating what the problems are, what the issues are, and that makes it much easier to sort of execute on solving those issues. I think the other thing that we wanted people to realize is that this report doesn't attempt to solve all the problems, really. This report is about recognizing what the challenges are, recommending a path forward so that we can then begin to muster the resources and the enthusiasm towards moving towards developing solutions. We added one more exchange model, thanks to the buildingSMART Italy chapter, really talking about recommissioning. I will admit it was a third rail sort of for me I didn't want to address, but they did a really great job in providing sort of an exchange model summary that we could include. And again, it is one proposal, it is the beginning, and we can always address this in other ones. And, I think, as I said before, we're not solving all the issues for BIM and BEM, but we really want to see if we can make some progress in developing interoperability solutions in these workflows. So a lot of times there's this struggle between, well, what could be done, what we want to do, but what we can or probably should do. I realize there's a lot of, points of view that say, well, we'll just do this all in one model, or we'll just put it all in the hands of one person or one stakeholder. But that's not realistic. And so how do we balance what might be an ideal way of working versus what is actually practical? And as I said before, as a result of this report, what we began to realize is that there's a lot to unpack. There is a lot to unpack. There are so many technologies, not just on the BIM side, but also on the building energy modeling side. And they also are built upon different types of methodologies, different types of algorithms, or even concepts of how to look at building energy modeling. Yes, physics are physics, right? There's the physics of temperature and heating and cooling and all that. But how do these platforms then do their simulation analysis are often different. And, we want to be as technology and methodology agnostic as possible so that we can have the broadest range and opportunity of impact. There's lots of standards out there that are used and some not at all. And, there are a lot of stakeholders also involved that it isn't always clear what their roles are from project to project. We're also dealing with a lot of different types of projects, from renovating existing homes to multifamily dwellings to, office buildings and anywhere where humans are spending much time and, are spending a lot of energy in order to spend their time in those buildings. And again, looking at what are the requirements, that there's no single set of requirements for everybody, but these vary from region to region. So as I mentioned before, we did develop a set of exchange models or data exchanges within the life cycle of a project. This was not just pulled out of thin air. We had a small group of building energy modeling consultants and experts, and along myself coming from an architectural background, really talking about the potential. And again, these are proposals. They're not set in stone, but what they represent is a starting point. And I think sometimes the hardest thing to do when you're presented with a problem is coming up with everything from scratch. What we want is these projects to move forward and revise what we've done. Take in what we've done, do a good analysis of it, and then see what's necessary to adjust or change to move forward. And as I said before, we originally had about 11 of these, and then we added the recommissioning one. And it is an important one because this is an important part of much of our work in not just tearing things down and rebuilding and building new ones, but also refurbishing existing building stock. And then, as I said before, there's the openness to establishing even more use cases. And we'll actually see an example of that from Mirbek and Gianluca. Again, and, to sort of, wrap up the summary or the results is, the whole intent is to state this problem in a way that everyone can understand, that we have a common agreement or a consensus agreement on the facts that are there, and can understand the complexity, so that we can come together as a community and really talk with each other. I will say that in the formulation of this report and a lot of the research I did, I always felt like that the stakeholders were talking at each other or past each other. And I think there's an opportunity to really sit down and say, okay, I think we understand everybody else's points of view. Now let's sort of say, obviously there's no simple solutions. So let's start to work together to start working on what are those possible solutions. And I think another key thing about this is that we recognize that an IFC-based workflow or an IFC-based exchange may not always be the solution. But that if there are other open standards, there are other technologies that are open and people are willing to leverage, that we should recommend those and leverage them. So again, at the latter part of this, we'll talk more about how we move forward and how we'll engage over time in order to move forward. So with that, yeah, what I'm going to do is I'm going to turn it over to Mirbek.
So good morning. Good morning and good day, everybody, wherever you are. I would like to thank you all for joining us today. Thank you, Jeffrey, for your great presentation. Now we will, like you mentioned, cover the second part. We would like to give you some insight how to work with use cases, and this is just an example of one use case that you would probably find controversial in some cases, but we wanted to show that not only IFC plays a major role in BEM, but also so I'll try to talk louder. So if you don't see and hear me well, so I will try. Is it better? Okay. This is a controversial point. We mentioned several times that not only IFC may place a major role, but all other related standards. And one standard is BCF, the BEM collaboration format. That could be used not only for like classical clash detection, where you think that it's only for one use case. No, we want to prove that it's also possible to bring this BCF for other purposes. And this is one of the purposes which you could imagine will be profited from sustainability consultants, everyone, or energy auditors, also from building owners, because the building owners is the most important there. They want to have their building be most efficient. So this is a topic that we brought together with Gianluca and Jeff to show that the BCF together with issue management is a really major aspect where you can communicate together with your partners and different disciplines. This BCF can be classically being implemented at the planning stage really often, so that you bring your BIM model into perfect shape. We haven't seen that, or we have seen really rare that BCF being implemented at the construction side or the operation stage. So this is mainly focusing on operation and maintenance, and in this case for retrofitting. So having the challenges to build a house, I'm just giving an example of the house here, the housing example. Here you have a building in existing form, or you will be building it from scratch, right? So you have a building in two cases. I will not describe BCF. There are a lot of resources. We have, I guess, several pages webinars available on BCF on what is it is. Of course, it's a buildingSMART standard. It could be as an analogy for WhatsApp, but it's more related to the communication and for quality control. So what kind of issues in industry we have? How or where we could see this kind of implementations? Just a classical, there are clashes, right? Yeah, it can be soft clashes, hard clashes, I can see in this example, or time clashes. So also very major aspect in on construction, especially on construction side. So this is examples that we thought might be interesting, not only for clashes, but also for different applications. And what about asset management? And we thought, okay, as soon as you have your as-built model, you will start to bring your dynamic information to it. How? You will not use an IFC. Yeah, it could be possible to use IFC as a static model, but you have something different. So as an inspiration that we saw that the video. You know this video. It's a well-known video introduction on OpenBIM, like what does OpenBIM for you. And there, as exceptional as this case, you will see that this is a case that explains of implementation of IFC and implementation of BCF and issue management on the left side. So you communicate dynamic information with the help of BCF and the static information like a building model. Doesn't matter in which stage. It should be, of course, implemented via IFC. Those issues in the building as a monitoring, issue analysis, issue management, action applications, this or issue evaluation is a stages, and these stages also covered in the Six Sigma. So efficiency is the most important aspect for us. How you would go through these aspects. So BCF for owners. Besides of the model communication for facility management, you also have important aspect that the building owners will be also engaged in it. And this is, I guess, is a key or crucial point. The building owners are always have to be informed what's going on the construction site. If you don't communicate with them, later on it will cost a lot of money because but the client will say or will give a feedback that something is wrong and you have to change the maybe a material on the site. In this case, we would like to cover some methods. So if you have an existing building, so there will be some cases how to digitize. If you got lucky, you have, so in case one, you don't have any drawings. You got, yeah, classical, like Jeff already mentioned, and it's already known that there are, most of the buildings are existing buildings and moreover, and not energy efficient. So, and how we will document them, how we will document this building. So we use classical methods like photogrammetry, laser scanning, and or just in the old school style, taking a folding rule and measure the building and openings and so on. Or you go, if you have a case too, when you have a paper building, it could be, I mean, a paper model, blueprints, whatever you have from 19th century, from 17th century, I don't know, if some kind of old building preserved, then probably you will have some very old model drawing. And this drawing you should digitize and later on bring it to IFC model. So this is a case where we thought, all right, we'll bring this model. After all, you have to find out what kind of issues you will face, what kind of typical problems we will face with an existing building, because we're talking about existing with the quality control. So the typical cases of the existing building, it could be, of course, and also a new building, but currently I'm showing you examples, some typical example that you have a leaky doors, windows, the building envelope is really not a bad shape, let's say. We have thermal bridges, we have deterioration of insulation material, you have some mold growing and so on. This is harmful also for indoor environment. So it's important too, the important aspect, and not only for building assessor, but for the building owner. And that's how you would bring a case. You bring your energy auditor or the energy consultant, sustainability consultant who will do the case. That person in the classical, coming from that area, will bring his tool, or he or her tool, in this case, blower door test with thermal camera, for documentation. Let's do this on a small scale building. As you can see, the house of my neighbor, we did it, and yeah, that was not a big deal. Yet, as you can see, thermal images that I'm showing you, you have to locate them. After all, the classical way, you bring your paper. If you don't have a model, you have to somehow document them, and this is really tricky job. For this building, yeah, it might be recognizable. It might be at the end trackable to track all these issues. Still, the small scale also brings you some disadvantage, because at the end, if several years later, the building owner will say, "Oh, do you remember we had a leakage on that corner? Sorry, in which corner? It was last year, so I have to follow." And if I have on a paper, it will be difficult. Then this is I'm coming to the methodology. The methodology now we'll see. But what we will have if you have this building, so it's a skyscraper. I did the blower door test for this one, and you have there are methodologies. You can do the floor to floor, or if you have a huge truck with a fan that can do the whole building envelope and open the entire doors. That's not the case here. The methodology here to take samples of each floor, so that takes, I don't remember, it was in total 40 floors and like 60, 70 meters tall building, is a residential building. So you can see, imagine all the samples that they did. You have to locate them, you have to mention and document all that potential leakages, thermal bridges, whatever will cost your time later on finding them. So this is like now coming a point. The thing that the requirements that we are facing, it could be a passive house building or LEED certified, the candidate for LEED certification. For BREM, there are requirements to have an airtight building. Also, American USACE, United States American Corps of Engineers, also requires airtight buildings. So you have to perform this blower door test. You have to document them. So this is a client requirements, and you have to meet them, and you have to document and prove that this building is airtight enough. So then we go through the requirements. You will definitely address. And then in this case, the idea comes that we will use BCF to document it. Just as a real example now, I will show small scale. So we took as a proof of concept. The scale, the proof of concept is usually done in a really small scale, and this is a containerized building that we built in the factory. In the left case, it left the factory being tested for blower door test and the thermal imaging, but it performed even the energy simulation on it. And later on, for the model is based two different models. There are IFC4, IFC based on IFC4 coordination with, and also IFC2X3, IFC4 reference with, and IFC 2X3 coordination with. We use these MVDs to export for specific use cases, because not every use case will be covered in one model. It's cliche that one model will cover everything, even super detailed. No, in some cases for daylighting analysis. I will mention it later on. So this building was done, and we performed some model checking and realized, yeah, there are some cases where you have to improve that as well as for DFMA, for prefabrication. There are some shortages that you cannot cover everything. Yet with the basic stuff, you can cover most of the stuff that you can see there already mentioning some important building components. The building, imagine, had a time period of 10 years, and this kind of containerized building being used everywhere as maybe as a residential for some temporarily disaster relief containers or accommodation, or very common for construction site, foreman sitting on the construction site and sitting in the building and freezing in winter because they have drafts and problems in the building envelope. So, and this is a case that we mentioned. Did the perform the same blower data, same thermal imaging to document, and we found out several leakages here, building thermal bridges, and some other issues that we could potentially already be eliminated at construction site. There are a lot of hand workers, so so this is the case. This, how we could check what can we perform, like capturing water usage, run classical energy monitoring the entire year, to have a time for that, building conditions for the whole assets, like the whole components, walls, windows, doors. So the building envelope should be assessed. You can perform also R-value measurements for specific insulation, or in this case, sandwich panels. Blow door measurement, like I mentioned, thermograph image. You can also perform energy modeling, building energy modeling. Right after that, and have your inputs from your measurements, and you'll see at least more realistic inputs rather than assumptions. That's how you get this information. And those information to be already proved, because even the air tightness with additional insulation brings you 9% energy efficiency already on top without additional insulation. So imagine if you already change something on top, you improve the insulation, you improve all the components, eliminate thermal bridges. So that will be a lot of improvements. In addition to changing some other stuff like LED, installing LED lamps and so on. So here's a narrative according to Passive House Institute. This is also being used for national, because we were talking international certifications like LEED and Passive House also. But in Germany, as an example, in all other countries, there is, or in California, even in the states, they have their own, within the state, their own requirements for building code. So this codes also require the building a blow door test. So you need to communicate this requirements somehow, and these measurements should be documented. I'm repeating again. Why? As you can see in the picture, that typical classical or typical issues like installation of building equipment, and you see this could be long ago eliminated. The opening for hose for the AC unit, and you can see the on the thermal image how we so much conditioned air is leaking, or as you can see the thermal bridges on the corner or connections of the container. So this is a really issues that you daily can confront, not only in construction site but in your own home. During the last summit, we presented some examples that we practice use case examples directly on the video. Currently, it's not possible to show them, but we proved that building energy modeling could also give some inputs. And at the end, with the help of BCF, you can perform all these measurements and document them directly in their building with the help of issue management. As you can see, we performed some improvements in the building, and how we can communicate with them through BCF. We put one issue management on the platform. There might be commercial, just examples of BEM Collapse mode, Solabri, and I can give you some example just a second after. But I wanted to just one video so that you will be able to see what we're talking about. So this is building. As I can see, we can transport information, not bring your location of the issue, map them, and change it as a report. The building assessor, in this case, sustainability consultant, or I don't know, energy consultant, will be able to see the real location of that measurement, the location of issue that he or that person found during the assessment. And the most important, this will be at the end and issue management, and the BCF will be sent to assess architect or maybe other parties, but most important to the client. Client will be informed, and it's a common known that there are a lot of different open possibilities to show that you have your, as you can see, have your building being documented. And this is a dynamic process because you will have your issues. You'll have a documentation when this is this case or this the issue popped up. Who did the improvement? And as you can see, there is also a blue dot test certificate attached some improvements. Who did the improvement? And post improvements image of the thermal image shows that all the leakages, all the thermal bridges were eliminated. This is the most important aspect. So I'll go back to the main page. And so we did performance, we documented, we communicated with other parties, and this is not within the IFC model. This is it's in our issue management platform, and this issue management platform documents with the help of a BCF, and all the information, including certificates and requirements, could be also transported with BCF. And well, just an additional example, but I wanted to show this that within the building you can also communicate the same way the reports or just the intermediate reports of your simulation. This is important here, building energy modeling. The simulation output telling their architect or I don't know, prefabrication company, could you please check that the building model will be improved because our current simulation of a daylight is not passing our requirements. So this is maybe some location of windows be improved or the skylight installed and so on with a clear with a solar protection. So I will pass it now to Gianluca. Gianluca will show you the similar example and different perspective. And Gianluca, the stage is yours.
Mirbek, the battery is gonna die. Just saying.
Oh, okay. No,
Get your power cord.
no, it's not battery. It's fine.
All right. Hello, everyone. So my name is Gianluca. Genova, I will also now just add one particular use case on what Mirbek was presenting and Jeffrey as well so far. So actually, it's a use case that we already presented in the previous virtual summit. So we actually integrated this use case into the in this particular work or project that was just presented. So I will just try to show, to remind for those who already saw it, quickly go through it, or for those we'll make it really fast for those who see it first time. So this is, it's about a primary school in Switzerland. It's in Rapperswil located. So there's a building owner who actually is willing to renovate the buildings, of course, with the idea of optimizing the buildings in terms of energy, improving the envelope conditions, justify or identify the problematic parts of the building, but and he wanted to have, or in that case, it was a he, the building owner, wanted to have a really very efficient way of documenting these things, and also to make a really fast cost estimation of the renovation, and also be prioritize the potential parts that can be renovated. So for those, of course, this is a typical case where an existing really old building from maybe it's already mostly 80 years old and it doesn't have any particular plan or any digital layout that we can start to work on. That's why we suggested, okay, we need to, first of all, for this existing building, make a digital capturing to have a good digital basis in order to make the documentation. So what we did here, we use latest capturing technologies like LiDAR sensors, drones, 360 cameras, in order to actually capture the building, as you can see here, and actually try to get the best from this particular sensors, what we could, in order to get a really cheap, let's say, geometry that we could use also for documentation. And here comes in the thing that where we create this mesh model in combination of 3D scan from interior, from the facade, from the roof, and combining with 360 images, we had all the things that we needed in order to create a geometry so that we can actually activate any kind of BCF workflow. And that was kind of a cheap compromise, but it was doing the task very well. So then we created this model and then merged also 360 images in that will look like this. From every classroom, we do have a 360 image. We would able to differentiate every level, every classroom, able to actually integrate a variety of pictures, issues, wherever we saw one. The experts walk through the building with a camera, just taking pictures from the particular elements which was problematic. It could be, it was sometimes a window, sometimes a door which was leaking. The thermal pictures that Mirbek just showed you could be also integrated in this one, and that allows a really good 3D documentation of the building, and that was the basis where we discussed with the client together about the possible renovations work. So there are some videos. I will not go through all of them. So just here a remark, probably after me, Mirbek will show how this project is integrating use case management. There you will have the whole full documentation, everything what we presented today also documented in that way so that actually you can access also afterwards. But just I will go through some picture and see if there's any YouTube link which could be particularly relevant. So Mirbek, let's hope I don't lose this page again. So, all right. So here you can see that that's how we added. We could add in a model. Let's call it information model, which is based on this mesh model. Any kind of issue, we in a certain room, in a certain level, in a certain position of this model. So what it was doing, of course, we will not have the windows as an element, the doors as an element. Of course, this model can be, geometrical model can be compared to a sculpture of the building. But what it was able to do is it was able to locate any kind of point which is associated with an issue or any kind of picture which was associated with an issue as well. And this was the way that how we added the issues to the model. We could just click a screenshot and okay, now maybe you have to help me, I guess, for that. Right. So as you could see, so while we used 360 images and the mesh model in combination, the reason was it's really easy to identify material or texture, any deficit from a picture if you particularly saw this and document it. But the picture doesn't have any spatial context. It doesn't can relate it to any room or space or any kind of like level or whatever we know from the BIM world. As you know, in a traditional way, what we would do, we would create a folder for every single room, put all the picture inside, and hope that the pictures are really documented in a really nice order. But in this workflow, you don't need to really follow a certain path. You can just, as an expert, go whatever you think is relevant to, or start to analyze the envelope, and then you can just open issues. And the reason, because we use that, coming back to the first statement, why we use 360 image in combination with mesh model was, mesh models are really good when it comes to dimensions, like having an understanding of the volume of the space, of orientation, all this capturing tools, this cheap LiDAR tools, which even you can use now for an iPhone or any kind of smartphone, which has a LiDAR sensor, is able to do actually a scan, There is also from Leica this BLCAT to go, which allows you to make really mobile scanning. But then these are really bad quality of meshes when it comes to texture and color. So it's not really good, in terms of recognizing any kind of failure or deficit in the building. So that's why the only trick was here to merge the 360 images with the mesh and kind of have the orientation wise together, so that actually the issue was able to be illustrated both in the mesh and in the picture, which will help again the experts to actually have a better documentation. The cool thing of this BTF workflow was that actually it was not just a documentation in terms of just having a picture with a location, with a text located in the model, but also it was good because then we could actually export this particular issues as BTF and send it further to another contractor or user to identify the issue and make maybe a bit out of for that particular issue, and then send it back, and also storing all this kind of communication in terms of in a form of BTF. That was, I think, here the most innovative part of it, which allowed us to do examination of the building without really writing, let's say, tens or hundreds of pages of report, just trying to document all the deficits in a really digital workflow. So that was it. Let me see.
Let's let Mirbek step back in and sort of go through the use case management tool now that
that
you're
will be
in
really
it.
good. So that will be actually good insight for everyone. Yeah, sure. Giving back.
So let's have just a quick review, Mirbek. Just kind of show everybody when we're talking about moving forward with these use case projects. This is really the primary interface for it. Yeah, go ahead.
Yeah. So I will come closer. So this is a primary tool, like we said. I will go through some most important aspects. Yeah. Currently, you see the backend part. Right. If you know this is UCM is a service of buildingSMART International, also offered by local chapter. If you have a chapter, you can contact them, and they will take care of the use cases that you potentially have in your working groups and your projects or whatever. I'll go through the pages. If you can see that if we go to the main part, this is a front end. I will start from front end. I think Leon did yesterday. He made a small introduction of and they used proof-of-application of Python. It's a really good use case because also coming from Germany and Switzerland. The project you can find with a keyword or with a, I don't know, or you can filter them by language, by room and chapter. So that current use case that we're currently presenting, you will be finding it here. It's not yet published because there's some small updates will follow after the summit, and we will definitely inform you about it. As you can see, these use cases are all filtered within the chapter. You can, if you're registered, and we will definitely recommend to register, because you will not be able, without registration, be able to see specific parts. And when you click onto the use case, like here's an example, as you can see, you can download the PDF out of it. The PDF will, as a documentation, and necessary information like process maps, potential exchange requirements, you will not be able to see. And we recommend that you do your single sign-on registration. And I will go back to this backend side, and they can directly for our use case. There are different types that you map to these use cases with specific stages, with resources, with sources. You can pack your original, let's say, publications or refer them simply. And this is a case where you have all this metadata. This is very important. Who is involved? And if you go to the use case here, you can see the related standards, related buildingSMART standards. Most important that you have them as a tag You can, in some cases, you don't have to even make necessary inputs, but that will be directly linked to existing repository. Process map, you can integrate a process map that we skipped this time because we already presented several times, and this is the one particular, this is a whole process map. Why I packed it here? Because we have the most important information that you need for blow-up test or simply retrofitting information. That should be at the very, very beginning of the requirements. Then you will achieve your efficiency. Otherwise, in some cases, when the client says, "Oh, I need lead gold, whatever," when the construction are already almost finishing, then you'll have a problem as a sustainable consultant. You have to make a lot of improvements, but it will be real too late.
And I think, one of the important parts you see about this use case management platform and the setup is that, documenting those processes that, as a part of the original sort of IDM workflows or process, that creating these business process models is very important. And one of the things that I believe that they're working on next for the UCM service is trying to integrate a BPMN tool directly into the service so that everyone can use the same tools. Now, in this case, Mirbek has used Camunda.
It's Cavemo, Camunda, because as you can see, it's easy. We directly link it, and you don't have to even make a necessary. You can make an export as a BPMN to 0 as a like I see for processes, but you can also create a link and simply link, because not everyone can see the details and they have to install it, so it should be there.
So the great thing about this is then we start having a common ground in which we document processes and we talk about the details of them, and hopefully are able to share these in a way that people can see where particular use cases might interact, overlap, or even share exchange requirements.
Yeah, as you can see, good that you mentioned about the exchange requirement. There are different tabs. You define your use case, you define your processes, you define your exchange requirements. This is, by the way, two components. This process maps and the exchange requirements are main parts of IDM. So it means if you, as a use case, started defining those two main components, you'll be already 50% way for your IDM. And IDM is very important standard, ISO standard as well, to cover this specific topic. As you can see, I will not go through the requirements, because this is a bunch of requirements that you need to perform the energy assessment. And the requirements that which tools, or excuse me, not tools, but general requirements how to perform. So based on the in the report we had exchange models. Those exchange models were interlinked with process map, so you know what you need at what stage and who needs to deliver which information. This is again IDM, and as you can see, you can, if you have a chance and the knowledge, you can directly provide the additional links or at least mention IFC, which entities coming into your application, which properties, related properties, or I mean property set and their related property, in this case like infiltrate. As you can see below, door has infiltration. So we need to know what's the infiltration. You can pack it even in BSTZ. Again, additional it's not standard as a service. So you find this service and so on. And the additional tool that is it's really new. It was not there as a tools like software tools and services I can use. We packed in two cases like tools. In this case, you can have a BEM outering tool, because if you don't have a building model, in our case, you should, I mean, you or architect should create a model, or you have a model. delivered by architect. This is the second case. And you have your tools like blower door test, NMM meter, I don't know. I've seen Weaver model checker. Most of them are also even open source. CDE platform, Fokker, or thermal image camera, and media. You need your model, you need your certificates, BCF, and so on. So this is, at the end, you can generate an output. You can also export the PDF. You can, as soon as it's published, as you can see, this is a preview. It's not yet officially published. We will do that land, and you will find this one on the front end. Yeah.
Great.
Now,
let me go
back to you.
Yep.
I have to stop sharing, right?
Yep. Okay, so thanks to Mirbek and Gianluca to really, get everybody to understand, examples of what we mean when we're trying to tackle projects moving forward. These are the opportunities to leverage standards to, meet these kinds of workflows. And I think that the BCF one is really interesting because it may, and rely on using a building information model from the very beginning. But what's really great is that then you can leverage BCF as Mirbek showed, to also enrich that data with other forms of data. Now, in those cases, it was images, but those also could be links to models from within the BEM tools, right? So, I think here's these opportunities to really explore. I think, so some of the comments in here was, we're talking about, well, what's this link with SEM? And, one of the ways that we've been trying to move forward is moving forward in a much more holistic way, is understanding that there is a certain level of, oh, hold on a second. Let me expand that. Okay. One of the points of the report is trying to get everyone to focus on, when we talk about building energy modeling, it larger and more holistically, is looking at larger contexts. So we really have to do a better job of looking at the context of life cycle cost analysis, or some people call it total cost of ownership, which involves those systems beyond just the building itself, right? Or what we immediately think of in terms of the building context. So we talk about carbon footprints. We talk about the connection to not just the energy grid, but then what are the effects in managing energy consumption at a building level, at a block or campus level, at a district or urban level, and then even beyond that. And there are opportunities if we expand that notion of what the BIM to BEM workflows and throughout the life cycle of a project looks like, that we can then begin to have those interactions with larger concepts or systems of either the input of energy and how it's used, and making a building not just, if we make a building more efficient, then obviously we can have an impact on how energy might be leveraged for an entire city or entire village, right? If you were to go in and accurately model the renovation capability of, say, 3 square blocks in a city of rundown buildings that are then going to be turned back into affordable housing, you want to know what kind of impact that has on energy consumption at a district or a network level, right? And then that can begin to then play out in terms of, well, what is our capacity going to be need for our grid? What is the capacity needed for, a particular area in the city? Do we have transmission capability for that? Or, what do we need to upgrade that in order to provide all of the new things that we want to do? Maybe it's, 100-year-old infrastructure, and realizing, well, we're going to modernize this entire city block or several city blocks. We need to update the infrastructure too. and look at those costs associated with making those efficiencies. I think, it's very easy to start at a very micro level and say, oh, well, as long as I solve these problems in making my room or my building more efficient, I'm done. And that's not true. So we're trying to expand everybody's notion of this to deal with both the macroscopic and the microscopic at the same time. And I think that's where we become to get more effective in making these changes as we want to reach these goals. So I want to move on to So what I want to do right now is I want to look into what are the next modes, right? What are we doing next? And so the recommendations from the report, let me zoom down here, there, let me do my zoom, is we want to, one of the recommendations of the report was to establish a BIM-BEM working group outside of any particular room, but then allows an opportunity for rooms and also external partners to communicate and tackle this process. First order of business of that working group, besides establishing a charter, is look at this idea of what does that life cycle process map look like? What are all those factors involved? What are all those opportunities when you, beyond just having BIM-BEM, but looking at this holistic issue and establishing what's necessary. Okay. Okay. Let me take about, what was my time now? Okay, let me take about 5 more minutes to go through these next steps, and then I'll turn it over to Bertrand. So the idea of establishing a BIM-BEM working group is trying to make sure that we have all of the necessary stakeholders on board. Again, we have to look at this holistically. We sort of have to establish communication that stops people talk past each other and starts understanding each other's point of view, and we start talking with each other to solve the problems. I realize there's a lot of experts in all the different corners, and they have their different views and opinions, but at some point we just kind of have to say, okay, well, then let's set that aside and let's look at the problem, how it's stated, and then what are the opportunities to fix it. So obviously there needs to be the establishment of who's participating, a steering committee and its charter. And then this idea of the first order of business is really developing that roadmap, right? And the roadmap can be as broad and as deep as necessary, and those life cycle process maps. And it may not just be one, it may be several, and deal with those different micro and macro issues. So then the idea is prioritizing those projects, right? And I think the best place to start, and we've talked about this in the infrastructure and building rooms for asset operations handover, is because there's a lot there and there's a lot of opportunities, what you want to do is find the low-hanging fruit. And with that term, what we mean is what are the things that are high value, but they're a low threshold for development and implementation. We can have quick agreements, we can find quick consensus, and then we can move forward with developing these projects and getting them implemented. And again, we want to stress that it may not be that it's always IFC based, but we want to use other open standards and technology to make sure this is complete. We don't want to leverage proprietary things, right? We want to make this available. We want to make this agnostic enough that any 2, 3, or group of tools can share information. And of course, this then means coordinating with external partners on those standards and technologies and on these projects, and possibly funding and running them. So then, of course, the last step is launching these projects, is finding out who wants to be participating, what are the scope of these things, and then how do we manage them, fund them, and then get people training on the UCM so we can begin to document and then look at solutions with vendors and stakeholders to do that. So let me go in here to participants. Okay, I'm going to stop my share. And Bertrand, you are muted and you should have the ability to share.
So maybe I will quickly present the sustainability and energy management room that that we have, and trying to focus on how I see that our intention in this sustainability and energy management room is fully compatible with and complementary to what you say. And if I may, in your presentation, talking about energy BEM, building energy modeling, I was expecting to have much more things in really in the energy, and for what we are concerned in the energy management aspect. But still, everything you say is fully valuable and valid. So what we want to address in our sustainability and energy management rules is to accelerate the capacity first to design, to simulate sustainable and efficient building. Means behind that is offering to the different software editor some tools, some processes, some data, so that we can design efficient building in the future, of course, with new architecture, potentially new solution, and better optimization. So it's about electricity in the electrical network design. We start with that in our domain, and also to have efficient building in the power consumption in the operation. And this requires the ability to simulate the power consumption behavior and have, I would say, a full digital twin of the building. So if I go here, what we mean behind that, let's imagine that we have in a building, like it is the case today, sensor in many different places measuring consumption. This we can do. What is difficult to do today is, if we have a power consumption for a given power meter, and I will here mainly talk about electrical power, because we know that most of the consumption in the building today are essentially electricity. Maybe there are still some gas for HVAC, but mainly electricity. So a first difficulty is to be able to say, hey, this meter, what is it measuring, by the way? And to have a digital model, an IFC, electrical IFC, that can say, oh yes, this meter, it's here, it's located here in my electrical network, and I know it is the power consumption of that month for the lighting, or for the air conditioning, or for that floor, or whatever we need. And this today is a model like this is missing, and that's why we want to have an electrical model. We call it NEM. The second aspect, and this you totally addressed it in your presentation, is this meter or other sensors to be able to locate them easily and efficiently in the building layout, so in the BIM model. And that is also a second point, quite well addressed, or very well addressed, it's okay. And last but not least is to have the capacity to benchmark this 1,234 kilowatt-hours that was measured last month with a target. So behind the energy modeling, what I am expecting to have is to have a dynamic profile that will give to the facility manager or the building owner or whoever in operation to have a simulation of the consumption of the building per zone or per type of application or globally. And that this simulated consumption, of course, is dependent of the construction of the building. I would say the thermal behavior of the core and shell of the building. This, I think, is addressed already, but also depending on the different scenario or power control. Take a basic example. If we put a presence sensor in a room, how does it change this profile, or a luminosity sensor? How does it change this profile compared to a room which doesn't have this kind of sensor? So that is all the capacity that we must have in order to have a really efficient, I would say, power simulation and power management. And for this, we see three pillars, three things. First, what we call the normalized electrical model. We can see it as an IFC electrical, which is the capacity to have and exchange a model around the electrical power network. So the image of IFC is pretty simple. Then second, the capacity to simulate the electrical energy or the electrical power consumption, the one I mentioned. And the one I didn't mention also so far, still on the electrical network, is to offer the capacity to calculate and simulate the sustainability and life cycle impact of the network. Because here, from what we know by different studies, is that in terms of sustainability, most of the impact, mainly if I will look on CO2, is related to the power losses that we have in the network, power losses in the transformer, power losses in the cables, power losses in every electrical device that is heating. And that is very important. And to come back to the initial objective, then maybe there are some ways to think differently and to size differently the network. So that's basically the three pillars. And I think there are a lot of things to share with your room, especially around so the electrical model on one hand. And we are totally aligned. If we look in our, we'll go quickly, in our intention, or roadmap, if I can say, is to complete what you did in your document with a workflow, but looking a little bit deeper or a lot deeper into the electrical network workflow. So it comes as a complement. We mentioned about IDS is also to deliver the different IDS for the main electrical objects during this workflow, et cetera, et cetera. So I see a lot of complements with what we see. Unfortunately, I see time is getting.
Yeah. No, thank you, Bertrand. No, thank you. And I think, I think this is good. I'm glad that you also see the opportunity. I think in the existing, like I said, we have a bunch of proposed exchange models, but obviously, when I started the project and I started the report, it was, before the SEM room was put together. So that's why we've been working now to address this with more of the rooms, especially your room, because there is that common purpose, right? And yeah, the different domains and the different expertise, I think, play well into each other and how we can have an impact on both the building energy modeling, sort of how it's conceived of today, and then how that actually benefits from your group's vision of having an impact on those EU goals by saying, well, let's look at the electrical network. Yeah, I think it's a great opportunity. So we are going to wrap this up. And before we wrap it up, I'm going to say we still have lots of work to do over the next few months. And what my goal is before the next summit in Rome next spring, that we have a working group together, that we're able to have a plan in place, that we can look at the SEM Room's life cycle roadmap, and we can begin to, coalesce and have those touch points and bring them together, and then move forward in determining a plan to sort of start nailing down and fixing some of these issues. Like I said, I'm not trying to solve all of the BEM issues. I'm not solving all the BIM issues. What I'm trying to do is create those opportunities where we can solve the data exchange issues in ways that are meaningful, not just to the immediate purpose, but to reach those goals of being a more sustainable society. So thank you everyone for joining us. Again, thank you to Mirbek and Gianluca. Thank you, Bertrand, and all the members of the SEM Room who have been here, and our Building Room Steering Committee. That wraps it up. This recording will be made available through the EU Climate Pact website, as well as on the BuildingSMART website later on. And again, look out for when we make announcements about participation, and hopefully we'll see many of you there trying to tackle these issues. Thanks again.
Bye.